Okay, so in this video I'm going to have a look at deriving the divisor of a line segment formula. That's this formula here. So let me just explain this diagram here that we have. So what we have here is a line segment from P to Q. And we have a point on that line segment called OR. Now the coordinates of OR will be given by our formula here. This will be the x coordinate and this will give us the y coordinate. Now OR divides the line segment PQ in the ratio A to B. So, it could be 2 to 1, or it could be 3 to 2, it could be 10 to 7, it could be 10 to 1. OR divides the line segment in some ratio, A to B. So A is this part of the ratio, B is this part of the ratio here. And what we have here is the coordinates of P, which are x1, y1. So I could put in the coordinates of P here just simply as x1, y1. So you can see here you've got your x1 and here you've got your y1. The coordinates of OR are going to be just given by x, y. So the coordinates of OR here are just this x value here and this y value here. That's what this formula is going to determine. The coordinates of Q here are given by x2, y2. So again, I could put in Q here just as x2, y2. Now, the first thing we're going to do is just notice that I've drawn two triangles here. I've gone out from P out to this point here, which I've called M, and this is directly under OR. So in other words, the distance from P to M is just going to be given by the distance from here to here, the distance out to X, minus the distance out here to X1. And similarly here, you've got another triangle drawn here, and this triangle goes from OR out to N and then directly up to Q. So both these triangles are right angle triangles. Now this distance here from OR to N can be given by x2 minus x. So the distance from here to here is just x2. The distance from here to here is just x. So this distance here is just x2, which is this distance, minus x. We also have, by the way, our vertical lines here of each triangle. So we have the distance from M up to OR here. Again, that's just going to be the distance y minus the distance y1. That'll give us this part of our triangle here, this distance here. This distance here is just going to be given by y2, which is this distance here. So y2 is all the way down to here. If we subtract y, which is this distance here, that'll give us this vertical distance here. Okay, so let's have a look then. You notice as well, by the way, that these two triangles are similar triangles. And the reason that they're similar triangles is that we have here a right angle here, and this is a right angle here. And also you'll notice that this angle here is going to be the same as this angle here. Because this line here is horizontal, this line here is horizontal, these two lines are parallel, this is a transversal if you like. So this angle here and this angle here, they're both corresponding angles and they're the same. Also, of course, you can say that this angle up here then is going to be the same as this angle up here. So you have these three angles here are the same size as these three angles here. So these two triangles are similar. Now they're similar, so therefore we can say that the sides of these triangles are in proportion in order. In other words, we can say this side here divided by the length of this side here is equal to the length of this side divided by the length of this side. We can say the length this side divided by the length of this side is equal to the length of this side divided by the length of this side. And they're the two equations we're going to use to derive this formula here. In the first case, we're just going to derive the x coordinate, this part here. So let's do that. So we're going to look at this line here and this line here. So let's just write those down. Now, as I said earlier, this particular line here is given by x minus x1. This line here is given by x2 minus x. So let's just write down an equation, general equation first. We can say here that the distance from P to M, the distance from P to M along here, divided by the distance from R to N, that's the distance, this distance here on the other triangle, divided by the distance from R to N equals, I'm going to say the two hypotenuses here, which is A over B. This is in the ratio A to B, so I can say A over B. So that's equal to A over B. Okay, so that's the first part of my equation here. So what we can say from this then simply is the distance from P to M, we said, was x minus x1. The distance out here to x minus the distance out here to x1. So we're going to divide that by Rn, and that's just simply going to be x2 minus x. And again, that's equal to A over B. Okay, so we have our equation here. So I'm just going to cross multiply here. I'm just going to multiply the top by the bottom here. So I'm going to multiply this part by B, this part here by A, and they should be equal. So in other words, I get B times x minus x1, and that should be equal to A times x2 minus x. Okay, so let's just multiply out these brackets. So we get bx minus bx1 is equal to ax2 minus ax. Okay, so I'm going to put the two, remember I want to try and get x. This is our x coordinate here. So I want x. I want to know what this coordinate here, this x is here in our formula here, if you like. So I'm just going to I'm going to isolate this x here in my equation. So let's get all the x's together. Well, you'll notice here I have an x here, so that's just going to be bx. So I'm going to leave that here. I have a minus ax here, so I'm going to bring that over to this side here. So I'm going to add ax to both sides. So it's going to be plus ax on this side. I'm going to take this minus bx1 here, and I'm just going to bring that over to this side. So I'm going to bring this over here, and I'm going to bring this one over here. So that will give me, on the right hand side, ax2 plus bx1. Okay, so let's just move this up a little bit and look at what we've got now. So I have my two x's here. I'm going to factorize out the x on the left hand side. So I'm going to take x outside the bracket. That'll leave me with b plus a. And then on the right hand side I've got ax2 plus bx1. Okay, finally then I'm just going to divide across by b plus a. So I get ax2 plus bx1 divided by b plus a. And that's it. That's my x coordinate here. So if we just move back up a bit here, we have bx1 plus ax2. So we have a bx1 plus ax2. That's the wrong way around here, but that doesn't matter. And we have an a plus b here. We have an a plus b here as well, or a b plus a. You can switch these around if you like. But this is our x coordinate. This is where our x coordinate comes from. Okay, so that's the first one we've got. That's the left-hand side, or the first coordinate of our formula. So let's have a look at the second part now here. Okay, so what I'm going to do now is just look at the vertical lines here in our triangles. So I'm going to take this side divided by this side is equal to this side divided by this side here. So Rm divided by Qn is equal to A over B. So let's do that. Okay, so I'll do that here. Let's put a line down here. So I'm going to take Rm, the distance from R to M, divided by the distance from Q to N is equal to A over B. Now again, you can see, as I said earlier, the distance from R to M is just equal to Y minus Y1. So I have A over B is equal to Y minus Y1. In the other triangle then, Q to N is down here. That's just Y2 minus Y. That'll give me this distance here. So that's going to be Y2 minus Y. So I'm just going to manipulate this formula, same way as I did for X, and we should end up with the Y coordinate. So let's see, again I'm going to cross multiply here, so what I've got is A times Y2 minus Y is equal to B times Y minus Y1. Just multiply out the brackets now, so we've got A times Y2, which is AY2, minus A times Y is equal to BY minus BY1. Get the two Y's together, because remember, as we did over here, we got the X on its own. Here we're going to get the Y on its own. So let's bring the Y's over to one side. So what I'm going to do is I'm going to take this here and I'm going to bring it over to this side. And I'm going to take this Y here, I'm going to bring it over here. So what I end up with is, let's see, minus BY minus AY is equal to minus BY1 minus AY2. I'll just multiply everything by minus 1 just to make everything positive. So I get BY plus AY is equal to BY1 plus AY2. Okay, now I'm going to factorize out the Y here. So I'm going to take the Y outside the bracket and I get B plus A. You can probably see that it's very similar to what we did with the X. So what I'm going to do here now finally is just divide across by B plus A. Okay, I'll just do it up here. Normally I would work underneath here, but let's just do it up here to keep it all on the same screen. So we end up with Y is equal to BY1 plus AY2 all over B plus A. Okay, and this is the right-hand side of our formula, or the second part of the coordinate. So we got BY1 plus AY2 over B plus A, and that's our Y coordinate here. So this particular X here, and this particular Y here will give us the coordinates, the XY coordinates of any point along this line segment here that divides the line segment in the ratio A to B.